Hey everybody, welcome back to Quantitative Reasoning. Today we are starting Chapter 6, which is a little algebra review. We'll have 3 sections of algebra review here, and the first one is section 6.1, which is going to be all about algebraic expressions and formulas. So here we go. In this section we will practice evaluating algebraic expressions, and we will use some mathematical models. We'll also talk a little bit about the vocabulary of algebraic expressions, and we will practice simplifying algebraic expressions. So let's just jump right in. Okay, first of all, what even is an algebraic expression? An algebraic expression is just a combination of variables and numbers that uses the operations of addition, subtraction, multiplication, and division, as well as powers or roots. That's called an algebraic expression. And the only difference really between an order of operations problem and an algebraic expression is that the algebraic expression contains a variable. A lot of times we're asked to evaluate an algebraic expression, and what that means is to find the value of the expression for a given value of the variable. So they'll give you an expression that contains a variable, and then they'll tell you this variable is worth 6, or this variable is worth 10, or whatever number, and you'll plug that number in and then just work it like an order of operations problem. So most algebraic expressions do contain more than one operation, so like they might involve addition and multiplication, or multiplication, subtraction, and division. So there'll be more than one type of operation involved. And therefore, evaluating an algebraic expression correctly means carefully applying the order of operations agreement. So we are about to review that and just remember how that works. I'm sure that you've seen it before. So you might remember the acronym PEMDAS or the phrase, "Please excuse my dear Aunt Sally," and those are just memory aids to help us remember in what order the operations should be done. So you can think of the order of operations kind of like a traffic light that tells which operation has the right of way to go next. So it just keeps everybody in agreement as to what an expression is really worth. So first up in our order of operations, we know that we're supposed to perform all the operations within the innermost parentheses and work outward. If an algebraic expression involves a fraction, then you treat the numerator and the denominator as if they were each enclosed in parentheses. So if there are operations in the top of your fraction or operations in the bottom of your fraction, then those get treated like they are in their own little set of parentheses. So you have to do those before you move on. After you've done all the operations you can inside any grouping symbols that you have, the next thing will be to evaluate all of the exponential expressions, and then you will perform multiplication and division as they occur in order from left to right. Now this is a common place where people get mixed up a little bit, because if you look at the PEMDAS acronym, you know that the M comes before the D, and so a lot of people get the mistaken idea that you do all the multiplication and then you do all the division, but that is incorrect. Multiplication and division are equal in importance, and so it's kind of a tie as to which one gets to go first, and therefore we just take them as they come in order from left to right. And then the same thing with addition and subtraction. They are of equal importance to each other, and so we perform addition and subtraction as they occur, working in order from left to right. So one more time, grouping symbols first, or parentheses, then exponential expressions, then multiplying and dividing in order from left to right, then adding and subtracting in order from left to right. So let's go ahead and get into example 1. It says evaluate 4 plus 6 times parentheses x minus 5 to the third power for x equals 7. So this is our expression, and they are telling us that x equals 7, and they are asking us to find out the value of this whole expression. So the first thing to do is just substitute the 7 straight in for the x. Don't do any other math in your head, just substitute the 7 straight in there. and it will look like this. 4 plus 6 times 7 minus 5, close parentheses, all to the third power. Okay, now remember our order of operations agreement. So we do parentheses, then exponents, then multiply and divide in order from left to right, then add and subtract in order from left to right. And the first thing I see that needs to be done here is we can do the 7 minus 5 inside this parentheses. So I'm going to underline it to show that that's all I'm doing on this step. And then what I'm going to do on the next line is copy everything as is except the 7 minus 5. I'll put the result of that. So we know 7 minus 5 is 2. So we're going to have 4 plus 6, and then inside parentheses the 2, and then the exponent of 3. Now it would be possible to write this without the parentheses, but I kept them for a couple of reasons. One, we had them here, so I just kept them here. We know that parentheses can be used as a multiplication symbol, but also I wanted to make it clear what the 3 is applying to. So you can tell here that the 3 is applying to the parentheses. Well, it is still applying to the parentheses. So this exponent of 3 is only working on the 2. It is not working on the 6. So if you were thinking that 6 times 2 is 12, and then we would need to do 12 to the third power, you're getting ahead of yourself just a little bit. So we know that exponential operations take precedence over multiplication, so we need to evaluate this exponential expression first. So 2 to the third power would be 2 times 2 times 2. Now 2 times 2 is 4, and 4 times 2 is 8, so 2 to the third power is 8. So on the next line, I will copy this first part of the problem as is, but 2 to the third power I will replace with an 8. And again, I kept the parentheses, but if you wanted to at this point get rid of them, you could just write 6 times 8 with like a multiplication dot. Okay, now I only have 2 operations left, and that's addition and multiplication. So of course multiplication takes precedence over addition, so I'll do that first. 6 times 8 is 48. So on the next line I'll have 4 plus 48. And then all that's left to do is add 4 plus 48, and of course that is 52. And that's an order of operations problem. So let's go ahead and get another example here. So here's example 2. It says evaluate x squared plus 5x minus 3 for x equals negative 6. Now we are not going to go back and learn our sign rules in this class, but it is very helpful if you know them. And if you don't know them yet, but you would like to know them, then there's a playlist linked in the upper right corner here that has all the videos you need to watch in order to learn your sign rules. But you do have a calculator at your disposal, so if you want to just use the calculator for this class, that will be fine too. So let's go ahead and work on this problem. We can see that the value of x that was given to us is negative 6. So we're just going to substitute negative 6 in the place of the variable. Now, in order to keep from getting my signs mixed up, I am going to put the negative 6 in parentheses every time I write it, just so that the negative doesn't get separated from the number. So x squared will become negative 6 squared. See, the negative 6 is in parentheses, and that is important. And then I'll have plus 5 times negative 6, but I'll use parentheses as my multiplication symbol. And then I have my minus 3. Okay, now still thinking about PEMDAS, we know that we would normally start with parentheses, but if you look at these parentheses, they're actually just being used to keep the negative together with the number. There's nothing to do inside these parentheses. So basically the P step is done. So let's think about exponential operations. So we do have an exponential expression here. So we'll need to evaluate negative 6 squared. Now of course that is negative 6 times negative 6, which is positive 36. But I do want to point something out to you here, especially since a lot of you are going to be using calculators for this. So here's a little detail about evaluating exponents that a lot of people miss. So we just said that negative 6 in parentheses squared is negative 6 times negative 6, and that's positive 36. And that is what we're supposed to be doing here. But if you did not write the parentheses here, it would look like this. And now if you type this into your calculator, you're going to get a different answer because your calculator does understand order of operations. And the calculator knows that if there are no parentheses here, the negative is not actually being squared. So what your calculator will interpret when you type this in is negative 6 times 6. So it will not square the negative, and so you'll have negative 6 times 6, which is negative 36, and see, they're two different answers. If you put the parentheses like you're supposed to, you'll get positive 36. If you don't put the parentheses, you'll get negative 36. So that is just something to be aware of. And so that's why every time I substitute a negative number in place of a variable, I always just go ahead and put it in parentheses as a reminder to myself that that's the way it's supposed to work. Okay, going back to our expression, the next thing to do is this multiplication right here. So 5 times negative 6 will be negative 30. And then we've got our minus 3. And so now we're ready to do our adding and subtracting in order from left to right. So we'll just start here. So I've got 36 plus negative 30. That's going to be 6. And then we've got our minus 3. 6 minus 3, of course, is 3. And so that's the final value for this expression when x equals negative 6. And now here in example 3, we have an expression with two variables in it. And it says evaluate negative 2x squared plus 5xy minus y to the third for x equals 4 and y equals negative 2. So just like we did in the two previous examples, I'm going to rewrite this whole expression, but where it has x, I'll plug in 4. Where it has y, I'll plug in negative 2, in parentheses, of course. And so I'm going to have negative 2 times 4 squared plus 5 times 4 times negative 2 minus negative 2 in parentheses to the third power. Okay, now again, let's remember our order of operations. So we know that we're supposed to do any operations inside grouping symbols first, but when we look inside these parentheses, there's nothing to actually do inside the parentheses. Every parentheses just contains one number. So that step's done. So the next thing to think about is exponential expressions. So I do have two separate exponential expressions here. They are in different terms, so they're not affecting each other. So I can do them both in the same line. So when I go to the next line, I'm going to copy everything exactly as it is, except where I had 4 squared, I'm going to substitute 4 times 4, which is 16. So I'll substitute 16 there. And then negative 2 to the third power is negative 2 times negative 2 times negative 2. So negative 2 times negative 2 is positive 4, and 4 times negative 2 is negative 8. So I'll have a negative 8 here. So, all right, it's going to be negative 2 times 16 plus 5 times 4 times negative 2. See, I just left that because that's going to be a multiplication step, so I'll do that in just a minute. I'm just worried about exponents right now. And then I went ahead and copied down my minus, and then we said negative 2 to the third power is equal to negative 8. So I kept that in parentheses because it is a negative number. Okay, now let's go through and do all of the multiplication in order from left to right. So I have a multiplication here and here. And the first one is negative 2 times 16, so that's going to be negative 32. The second one is 5 times 4 times negative 2. So 5 times 4 is 20, and 20 times negative 2 is negative 40. So it's going to say plus negative 40. And then we've got minus negative 8, which I'm going to just keep just like that. Okay, now we're ready to do adding and subtracting in order from left to right. So our first addition is negative 32 plus negative 40. Now you can do that on the calculator, but we know that when you add two negative numbers, you add the numbers and keep the sign. So negative 32 plus negative 40 is going to be negative 72. And then we've got minus negative 8. Now, you'll remember from maybe middle school or way back when you first learned your sign rules, minus negative means plus. So I'm just going to write minus negative 8 as plus 8. Okay, now I'm ready to do this addition. So I've got negative 72 plus 8, and that adds up to negative 64. So that's our final answer for this example. Okay, now let's switch gears a little bit and talk about mathematical models. So an equation is formed when an equal sign is placed between two algebraic expressions. So if you have an expression and that's equal to another expression, the fact that you've got an equal sign between the two of them makes it an equation. And then if you take that equation and solve it for a variable that you're interested in, that's going to be a formula. So a formula is just an equation that uses variables to express a relationship between two or more quantities. The process of finding formulas to describe real-world phenomena is called mathematical modeling. So that's all we mean by modeling, is just finding a formula that mirrors a real-world situation. Here's an example for us. This is example 4. It says the bar graph shows the estimated number of calories per day needed to maintain energy balance for various sex and age groups for moderately active lifestyles. The mathematical model is M equals negative 120x squared plus 998x plus 590. And this describes the number of calories needed per day, M, by males in age group X with moderately active lifestyles. So the X is the group that they're in, and the M is the number of calories needed per day. So the question they're asking is, according to the model, that is, according to this formula right here, how many calories per day are needed by males between the ages of 19 and 30, inclusive, with this lifestyle? So you can look at the chart and you can see that they're divided into groups. So the age group from 19 to 30, inclusive, is labeled as group 4. That means in this situation, X equals 4. And so we're going to take that 4 and plug it into our model. So the number of calories per day needed for males in the age group 19 to 30 is going to be negative 120 times 4 squared plus 998 times 4 plus 590. So you can see here I just took the formula and plugged in 4 in place of the X. Okay, now we'll do it just like we did before. So the first thing to do is evaluate anything that's in parentheses. These parentheses do not contain any operations. The next thing to do is to evaluate the exponential expressions, and we only have one, so 4 squared is 16. 4 times 4 is 16. And then just keep everything else the same. Now we can do our multiplication. So negative 120 times 16 is negative 1,920. 998 times 4 is 3,992. And then we'll just add these together. So negative 1,920 plus 3,992 plus 590 gives us a final answer of 2,662 calories needed per day for males in this age group. And now if you look closely at the graph, you can see that males are represented by the yellow bar in each age group, and so they predicted a calorie need of 2,700 for males in this age group. Our model or our formula actually found 2,662 calories, so probably what happened is they just rounded. It's not a very big difference, but it is a little difference. Okay, now let's go on and review some of the vocabulary of algebraic expressions. I'm sure that you have heard all these terms before in previous classes, like if you took algebra in high school, you've heard all of this before. So the terms of an algebraic expression are those parts that are separated by addition. Terms are separated by addition. So if we have an expression like 7x minus 9y minus 3, we cannot determine the terms while there is subtraction here, or at least you have to think of it in its addition form in order to get the terms correct. So we would restate this in addition form as 7x plus negative 9y plus negative 3. So you can always replace a minus sign with a plus negative. And notice that because I did that, I went ahead and put the term in parentheses so that I didn't have a plus and what looks like a minus right next to each other. So the fact that I have parentheses here kind of helps me notice that, hey, this is a negative sign. So now it says 7x plus negative 9y plus negative 3. So when you're determining what the terms are, it's important to do that because terms are separated by addition. So now we can see that this expression has 3 terms, and they would be 7x and negative 9y and negative 3. Now let's talk about the parts of a term. So the numerical part of a term is called its coefficient. And keep in mind that whenever a coefficient is a 1 or a negative 1, we do not write those numbers down. So the term 1x would actually be written just as x, and the term negative 1y would actually be written as negative y. Now a term that is just a number and does not have a variable component, that's called either a numerical term or a constant. These are interchangeable, numerical term, constant. The reason that we call it a constant is because the value of this term will not change. Even when the variable changes value, the constant will not change value because it doesn't have a variable component, so it's constant. The parts of each term that are multiplied are called the factors of the term. So for example, if we're looking at the term 7x, the factors are 7 and x. It's the coefficient and the variable. Now, like terms are terms that have the same powers of the same variable factors. So for example, 3x and 7x are like terms, but 3x and 7x squared are not like terms because even though they both have the variable x, this term has a different power of x than this term. So they are not like terms. Why does that even matter? Well, like terms can be combined with each other by adding the coefficients together. So for example, 3x plus 7x is 10x because no matter what x represents, if I have 3 of them here and 7 of them here, then altogether I've got 10 of them. So like terms can be combined by adding their coefficients together. But 3x and 7x squared cannot be combined. So I have 3 of one thing, but I have 7 of a different thing. So I can't combine the 3 and the 7 and say that I have 10 of anything. So these just cannot be combined, so they would remain separate terms. And now let's talk a little bit about the properties of the numbers. So you've heard all of these names before, but a lot of people forget the names of the properties. Even though they may understand the property, they forget the name of it. That's because we don't have to use the name in order to actually use the property in a problem, but it is worth going back over the names so that you really know that you understand. So this first one is called the commutative property of addition, and it just says that A plus B is equal to B plus A. Basically, the translation is that order is not important in addition. A plus B is equal to B plus A, and you get the same answer either way. We can do the same thing with multiplication. So the commutative property of multiplication says that A times B is equal to B times A. So again, whether you're talking about addition or multiplication, the commutative properties just say that changing the order of addition or the order of multiplication does not change the result of the calculation. And you already know that from common sense. You know that 3 plus 5 is equal to 5 plus 3. Either way you get 8. And the same thing with multiplication. 3 times 5 is equal to 5 times 3. Either way you do it, you get 15. So where did this get its name? Well, you know that to commute means to change locations. Like if you say I commute to work every day, It means that you drive from where you live to where you work. You commute. You change your location. And these numbers are changing location. They're changing position, so they are commuting. Now let's talk about the associative properties. So the associative property has to do with grouping. And it says that if you have three numbers being added together, if you group the first two together so that you have A plus B in parentheses and then you add C, that's going to be the same result as if you have the same three numbers but you move the parentheses. So A plus parentheses B plus C. Now notice that the order of the numbers did not change. A, B, C, A, B, C. These numbers are not commuting, but we are changing the way they are grouped. So we are changing the way they are associated with each other. But it doesn't matter because it's all addition. The result will be the same. So if you add the first two numbers together and then the third, that's the same answer as if you add the last two numbers together and then add the first. Either way, you get the same answer. The same thing happens with multiplication. So if we have A times B in parentheses and then we multiply by C, that's the same as if we have A and then multiply by B times C. So in this case, you would multiply B times C first and then multiply A times that answer. It's the same result as the other way. It doesn't matter just as long as all three numbers get multiplied together. So all the associative properties say is that changing the grouping of addition or the grouping of multiplication does not change the result. Again, it's a common sense thing that you already understand, but we just forget the name of it sometimes because we don't have to use the name all that often. Okay, now let's talk about the distributive property. And this is one that every algebra student knows, so I'm sure you've all seen this before. It says that A times B plus C is going to be equal to A times B plus A times C. In other words, the number that's outside the parentheses gets multiplied by each term inside the parentheses. So notice how this is different from the other two properties. With the previous properties, we either had all addition or all multiplication. The distributive property is the one that combines them. So here we're saying that A times the quantity B plus C is equal to A times B plus A times C. And if you have a minus sign inside the parentheses, it works the same way. So again, we're multiplying the A times each part, but the minus sign is going to remain. So that's going to be equal to A times B minus A times C. And so basically this is useful in algebra when you want to remove the parentheses from an algebraic expression. So if I had this algebraic expression here but it contains a variable and a constant so that these terms cannot be combined, but I still need to get rid of the parentheses, I can do that by applying the distributive property. So you see here no parentheses are needed. So let's get a little example here. So I've got 5 times 3 plus 8. Now if we do this the way that we learned in order of operations, we would say that we ought to add the two numbers inside the parentheses first. So we would see that 3 plus 8 is 11. That would give us 5 times 11, which we know is 55. So that's one way to do the problem. But if we take that same problem and we apply the distributive property, then we're going to multiply 5 times each of these numbers. So 5 times 3, and then plus 5 times 8. Then we can say 5 times 3 is 15, 5 times 8 is 40, add the 15 and the 40, and we still get 55. So either way we do it, we get the same result. So that means that whenever the terms inside the parentheses can be combined, like they could here, you can do it this way if you want to, or if you prefer to multiply by these smaller numbers, you can do it that way too. It's really up to you as long as there are no variables involved. But where there is a variable term and a constant term inside the parentheses, you lose the ability to combine your like terms first. So you lose the ability to do this step first. And then in order to get rid of the parentheses, you have to distribute. So we would say 5 times x is 5x, and then plus 5 times 8 is 40. And that's as far as we can go simplifying that expression, because in this case we don't have a value for x. So now we're about to get into simplifying algebraic expressions. So it's really important that we all understand what we mean by simplifying. An algebraic expression is simplified when the parentheses have been removed and the like terms have been combined. And when you have more complicated expressions, there might be some other things to do. But for us, an algebraic expression will be simplified when the parentheses have been removed and the like terms have been combined. So here's an example. This is example 5. It says simplify 5 times the quantity, 3x minus 7, close parentheses, minus 6x. So, of course, we have x terms in two different places, and we will want to combine those eventually, but we can't do that while we have these parentheses in place. So we need to remove the parentheses, and the only way to do that is to distribute the 5. So we'll have 5 times 3x, which is going to be 15x, and then we'll have a minus 5 times 7, which is 35. And then we've still got our minus 6x. Now we can see that we have two x terms, so we want to combine those, and we do that by adding or subtracting the coefficients. So we have 15x minus 6x. We know that 15 minus 6 is 9, so if we combine the x terms, that's going to leave us with 9x, and then we've still got this constant term, which is a minus 35. And now notice that we have removed the parentheses and we have combined the like terms. The terms that are left are not like terms, so they can't be combined, and that means that there is nothing further we can do to make this any simpler than it is right now. Here's another example, and this is example 6. So it says simplify 6 times parentheses 2x squared plus 4x, close the parentheses, plus 10 times parentheses 4x squared plus 3x, close parentheses. Okay, we see here some terms that are going to be like terms, but they're not free to combine right now because of the parentheses in both groups. So what we want to do is distribute the 6 through the first group and distribute the 10 through the second group. So 6 times 2x squared is going to be 12x squared, and then we'll have a plus 6 times 4x is going to be 24x. Then we've got a plus here. Now 10 times 4x squared is going to be 40x squared, and we'll have another plus. And then 10 times 3x is going to be 30x. So now we've removed the parentheses, but we've still got some like terms to combine. So notice that I have two x squared terms, so we'll just add coefficients here. 12x squared plus 40x squared is 52x squared, because 12 plus 40 is 52. And then 24x plus 30x is going to be 54x, because 24 plus 30 is 54. And that's it. This expression is now fully simplified because it contains no parentheses, and the terms are not like terms. So all of our like terms that we had have already been combined. Okay, now let's talk about what to do if the number that you need to distribute is negative. So if a negative sign or a subtraction symbol appears outside of parentheses, then what you're going to do is drop the parentheses and change the sign of every term within the parentheses. In fact, what you're really doing is distributing a negative 1, because remember, when 1 is a coefficient, it's not written. So you don't see a 1 there, but you see the minus sign. So what you're really doing is distributing that invisible negative 1. Let's see an example of that. So this is example 7, and it says simplify the expression 3 times parentheses negative 4x squared plus 5x, close the parentheses, minus open parentheses 5x minus 4x squared, close parentheses. So in order to simplify this, again, just like the last example, we'll need to distribute to remove both sets of parentheses. So we'll distribute the 3 through this first set. So 3 times negative 4x squared is going to be negative 12x squared. then we'll have a plus. 3 times 5x is going to be 15x. Now for the second set, it looks like we're distributing a minus, but really you can think of it as distributing a -1. So distributing the minus through here is going to give us minus 5x, and then -1 times -4x squared is going to give us plus 4x squared. So you see what I was talking about when I said drop the parentheses and just change the sign of everything inside the parentheses. The 5x became minus 5x, and the minus 4x squared became plus 4x squared. Okay, now we're ready to deal with our like terms. So we have a -12x squared and a positive 4x squared. If we add those two coefficients, -12 plus 4 is -8, so that's going to give us -8x squared. And then on the x terms, we have positive 15x minus 5x. Those two add up to positive 10x. So I have here plus 10x. So our final expression is -8x squared plus 10x. And now finally, one last example. This is example 8. And notice here we have two sets of grouping symbols. So we have -2x plus 3 times bracket 7 minus, open parentheses, 3x minus 4, close parentheses, close the bracket. I don't want this to cause you to panic or cause you to stress out at all. The thing to do, just like with our order of operations problems, is always go inside the innermost grouping symbol and see what you can do. So inside here, can you combine any like terms? And the answer is no. But if you go out to the next grouping symbol, out to the bracket, there are some things we can simplify in here. So for example, we could distribute that minus and eliminate those parentheses. So let's keep everything the same, except let's just distribute this minus. So it's going to be -2x plus 3 bracket 7, and now we're distributing this minus. So what it's going to do is it's just going to change the sign of these two terms. So we're going to have minus 3x plus 4. And now we've eliminated the parentheses and we just have the closed bracket there. Okay, now inside the bracket, can we combine any terms? And the answer is yes. 7 plus 4 is 11. So now I'll keep what's outside the bracket the same. So I'll still have -2x plus 3, open the bracket, but now 7 plus 4 is 11, and I've still got this minus 3x, and then close the bracket. Okay, can you tell what to do next? So now we have 3 times this whole bracket, so we need to distribute this 3. So I'll have -2x, still there, plus 3 times 11, which is 33, and then minus 3 times 3x, which is 9x. Okay, one last step. We have 2 more terms to combine. So now we have -2x and -9x. -2 plus -9 is -11. So that's going to give us -11x. And then we still have our plus 33. So the simplified expression is -11x plus 33. And you know that it's fully simplified because we removed all the grouping symbols and we combined all the like terms. These two terms cannot be combined because they're not like terms, so this is as simple as this expression can get. Okay, I hope that this section was mostly review for you. There may be a few things that you need to brush up on, maybe improve your skills, but this is just a little algebra review for you, and we will do a little more algebra in the next couple of sections, so I'll see you there. Bye-bye.